Hey everyone, welcome to another episode of the Towards Data Science podcast. My name is Jeremy, and apart from hosting the podcast, I'm also on the team at the Sharpest Minds Data Science Mentorship Program. And I'm really excited about today's episode because I've been thinking about getting today's guest on the podcast for a very long time. I'm so glad we finally made it happen. He's actually in between a transition right now from Berkeley, where he's wrapping up his PhD. He's working at the Center for Human Compatible AI. And he's transitioning over into DeepMind, where he'll be doing some alignment work. His name is Rohin Shah. And apart from being a very prolific researcher in AI and AI alignment in particular, he is also the publisher of the AI Alignment newsletter, which is a really, really great resource if you're looking to get oriented in the space to learn about some of the open problems and open questions in AI alignment. I really recommend checking it out. We're going to talk about a whole bunch of different things, including the philosophy of AI, the philosophy of machine learning and AI alignment, ways in which it can be accomplished, some of the challenges that exist. And we're going to explore one of the most interesting proposals, I think, that Rohin's come up with, which is an idea about extracting human preferences from the state of the environment. So basically the idea here is that humans, through their activity, have encoded their preferences implicitly in their environments. We do a whole bunch of different things, different actions that reveal our preferences. And it would be great if we could have AIs look at the world and figure out what our preferences are implicitly based on the state of that world. And that might be a great way to bootstrap AI alignment efforts. And so we'll be talking about that proposal in depth, along with a whole bunch of other things. I'm really looking forward to the episode, so I hope you enjoy it. So without further ado, here we go.
Rohin, thanks so much for joining us for the podcast.
Yeah, thanks for having me here. I'm excited.
Well, I'm really excited to have you. There are so many interesting things that you've been working on in the alignment space in general. But before we tackle some of the more technical questions, there's an observation that I think anybody who's spent any time working on alignment or talking to alignment researchers is going to end up making at some point, which is that the vast majority of people in this space seem to come from the effective altruism community. And I'd love to get your take on, number one, what the effective altruism community is, what effective altruism is. And number two, why you think there's this deep connection between EA, effective altruism, and AI alignment and AI safety research.
Yeah, sure. There's like the overarching idea of effective altruism, the very, easy to defend one that doesn't get into specifics is just, with whatever money, time, resources, whatever you're willing to spend altruistically, you should try to do the most good you can with it and you should, think about that. And it's pretty hard to argue against this. I don't think I've really seen people disagree with that part. Now, in practice, effective altruism, the movement has a whole bunch of additional premises that are, meant to be in support of this goal, but are, more controversial. I think that a really, fundamental big idea of effective altruism is that of cause prioritization. Well, many people will say, okay, I want to have, say, clean water in Africa. I will work towards that. And they'll think about different ways in which you could get clean water to in Africa. Maybe you could try sanitizing the water that people already get, or you could try building some new treatment plants in order to provide fresh flowing water that's drinkable to everyone. And they'll think about how best can they achieve their goal of delivering clean water. But it's much, much, much less common for people to think, okay, well, should I work on getting clean water to people in Africa, or combating racism in the US? Which of these should I put my effort into or my money into? The main premise of effective altruism is you can in fact do this. There are actually significant differences between causes, and by thinking about it, have much more impact by selecting the right cause to work on in the first place. And so it's very focused on, the sort of take ideas seriously, actually evaluate them, figure out whether or not they are true and not whether or not they sound crazy. Mm-hmm. Whether or not they sound crazy does have some relation to whether or not they are true, but they are not necessarily the same.
Right.
And I think that ties into, why it's also such a hotbed for AI safety research. The EA case for AI safety, for work on AI safety, is that AI has a good chance of being extremely influential in the next century, let's say. There's like some argument that is debatable, but it doesn't seem like you can rule it out. It seems like at least moderately likely that, if we don't take care of how we do this, we might just, like, the AI system might take over, in the sense of like all of the important decisions about the world are made by the AI system and not by humans. And like one possible consequence of this is that humans go extinct. I'll go into this argument later, I'm sure. But
So
EAs believe this argument somewhat, and so then it becomes extremely impactful to work on. It sounds crazy, but like one of EA's, to me, strengths is that it separates what sounds crazy from what is true.
It seems like really the focus is there's this extra missing step that a lot of people don't apply to their thinking when deciding what causes to contribute to, what to work on, what to spend their lives on. And that is the step of going really like, what areas are going to give outsized returns on my time?
Yep.
And
exactly.
Yeah, I mean, I can really think back to most of the conversations I've ever had with people about causes, about charity. And it's usually focused on stuff like, what are the administrative fees associated with this charity? Oh, well, I want to donate to a place where all my dollars go to the cause, rather than asking the more fundamental question, is this cause actually going to give the best ROI from the standpoint of benefiting everyone or benefiting humanity? So it's sort of interesting that kind of thinking, a more kind of first principles approach, leads a lot of people to the area of AI alignment and AI safety. As you said, I mean, it makes sense. You've got this super high risk, high reward profile. What was it that drew you, for example, to AI alignment, AI safety work in particular, rather than any of the other? I mean, I could imagine bioterrorism. I could imagine all kinds of horrible things that could happen to us. But why AI alignment in particular?
Yeah. So my story is kind of weird. It's maybe a classic AI story in that, convinced by very weird arguments. But I, got into effective altruism in 2014. I heard the arguments for AI risk, within a year of that, probably. I was deeply unconvinced by them. I just did not buy them. And so for until 2017, I basically just didn't really engage very much with AI safety. I was also unconvinced of, basically, there's this field of ethics called population ethics, which tries to deal with the question of how do you compare how good different worlds are when they have different populations of people in them. And we don't need to go into the details, but it's a very confusing area. Lots of, impossibility results that say, like, you might want these like 6 very intuitive properties, but no, you can't actually have all of them at the same time. Stuff like this. So
would the idea here be like, is a world with 100 decently happy people better than a world with 1,000 kind of decent minus epsilon happy people? Is that kind of calculation?
That's an example of a question that it would deal with. Yeah. So anyway, I was like thinking about this question a lot in the summer of 2017, and eventually, I was like, okay, I think I actually should put a fair amount of weight, like not certainty certainly, but like a fair amount of weight on the view that more happy people is like, in fact, just means a better world, even if they're in the future. And once you put a decent probability on that, it starts looking, overwhelmingly important to ensure that the future, continues to exist and have happy people, because it's just so big relative to the present. And so then I wanted to do something that was, more future oriented, and I had, a ton of skills in computer science and math, and like basically everything you would want to work in AI alignment. I still was not very convinced of AI risk, but I was like, okay, a bunch of smart people have like thought about this. Maybe I should like work on it for a while, see whether or not it makes sense. And so then and that's what caused me to actually switch. And a year later, I like started believing the arguments. more.
That's so
I also
interesting.
saw different arguments.
So you were led by the quality of the people who were drawn to the problem more so than necessarily the initial arguments themselves. Like, do you remember an aha moment as you were working on the stuff where you're like, well, wait a minute, like this is actually for real. I can now see why, Nick Bostrom and maybe Eliezer Yudkowsky and whoever else was talking about it back then was onto something.
I never really had an aha moment. I think I remember at one point I was like, huh, I guess I now believe these arguments, but it wasn't like I guess I now believe that AI risk is, substantial and real, but I can't point to a like specific point in time where I was like, yes, now I believe it. I just sort of one day was reflecting on it and noticed, oh yeah, I used to not believe this and now I do.
That's so interesting. Yeah, it seems like there's a bifurcation between people who maybe, they read superintelligence or they read less wrong and they get really excited about the problem and really scared of it right off the bat because for whatever reason they're wired in such a way as to have that happen. And then people, yeah, who like you, it's like a slow burn and you ease into it. I guess this is
Yeah.
part of the problem almost of articulating the problem, right? I mean, if it takes that long to get people to think of this as a really important thing, do you have a strategy that you use when you try to explain to people like why is AI risk so serious? Why is the probability non-trivial that you think might have worked on you back then to kind of accelerate the process?
Yeah, I should note that like I still, I'm like not super happy with the arguments in like superintelligence, for example. And like I would say that it's like, slightly different arguments that are motivating it for me with, still a fair amount of emphasis on things that were in superintelligence.
I think a lot of people won't have heard of superintelligence, by the way. So if you
Oh,
want to
yes.
address any of the
Sure.
arguments that you raised, please feel free to kind of give that background too.
Yeah. Maybe I'll just talk about, the arguments I personally like,
Yeah.
since I can, explain them better. But just for context, Superintelligence is a book by, a professor at Oxford named Nick Bostrom. It was published in 2014, and it was the first, like, book-length treatment of, like, why AI risk is a thing that might occur and why we should think it might be plausible, what solutions we might seem like they should be investigated and stuff like that. I think for me personally, the argument I would give, so we're going to assume as a premise that we build AI systems that are intelligent, like as intelligent as a human, let's say.
Mm-hmm.
And we can talk about that later, but that's a whole other discussion. I'll just say that, I think it is like reasonably likely to happen in the next century. But for now, take it as an assumption. One thing about intelligence is like, it means that you can adapt to new situations. Like you're presented with a new situation, you like learn about it and you do something, and like that something is like coherent. It makes sense. So one example I give of this, of where we see this even with current neural nets, is a specific example from GPT-3. So I believe viewers will be familiar with GPT-3, but if listeners, not viewers, but if not, GPT-3 is this language generation model that OpenAI developed and released recently. And I think I liked one particular example, which comes from the post giving GPT-3 a Turing test, where the context to GPT-3 was a bunch of like questions and answers, and then GPT-3 was posed a question: how many bonks are in a quote? These are nonsense words. You did not mishear me. And GPT-3, like in some sense, this is outside of its training distribution. It has never seen this sentence in its training corpus, presumably. It may not have even seen the words, bonk and quoit ever. So it's, actual distribution shift, and, you're relying on some sort of generalization out of distribution. Nonetheless, I think we can all predict that GPT-3 is not going to output some random string of characters. It's going to probably say something sensible. And in fact, the thing that it says is, there are 3 bunks in a quoit. Why 3? I have no idea. But it's like sensible in some sense. It like produced an answer that like sounds like English.
And we've all been there to some degree if we write exams or whatever.
Yeah.
We're asked how many bunks are in a quoit. We haven't done our studying, and hey, there are 3 bunks in a quoit. There we go.
Exactly. Right. So like in some sense, GPT-3 did generalize. It like generalized the way a student taking a test would.
Mhm.
In the original post, this was taken as evidence of like GPT-3 not actually being reasonable because it doesn't know how to say, this question is nonsense. But then a follow-up post was like, actually, you totally can get GPT-3 to do that. If you like tell GPT-3 that, if in the context you say whenever it sees a nonsense question, the AI responds, yo, be real. Then when it's asked how many bunks are in a quoit, it says, yo, be real. So, it's got the ability to tell that this is nonsense. It just, turned out that it generalized in a way where it like was more like a test taker and less like, somebody in conversation. Did we know that ahead of time? No, we did not. And I think this is like, we had to actually, run GPT-3 in order to figure this out. Right. I think AI risk is basically like this, but like, supercharged, where your AI system, if it is human level intelligent, it's like definitely going to be deployed in new areas, in new situations that we haven't seen before. And we just don't really have a compelling reason to believe that it will continue to do the thing we were training it to do, as opposed to something else. Like, in GPT-3, what were we training it to do? Well, on the training data set, at least, we were training it to do whatever a human would write in that context. But like when you see there are 3 bunks in how many bunks are in a quoit? What would a human do in that circumstance?
Yeah.
I don't know. It's not really well defined. And, GPT-3 did something sensible, but like, it's not, I don't think you could reasonably say that it was, doing what we trained it to do. It just did something that was coherent. And similarly, if you've got, AI systems that are human level intelligent or more, taking like super impactful actions upon the world, and they're put in these new situations where like there's not really a fact of the matter about how they will generalize, then they might, take actions that have a high impact on the world that aren't what we want. And then, as a maybe intuition pump for why this could be really, really bad, like human extinction level bad, one particular kind of distribution shift is, you go from the training setting where, humans have more power than the AI and can turn off the AI, to like the setting where the AI is sufficiently intelligent and sufficiently widely deployed that no human can like, or humanity as a whole cannot like turn it off. In that situation, that's a new situation. The AI has never been in a situation where it had this sort of power before. Will it use it in some way that will it generalize in some way that was different from what we expected during training? We don't really have a reason to say no, it won't do that.
Is there an analogy you think here with child rearing? I mean, I'm just thinking of here intergenerational human propagation, where our ancestors in the 1600s, at least in the West, I'm sure would be absolutely disgusted by our vile ways today, the way that we deal with sex, the way we communicate to our elders, the way that we manage our institutions and so on. All our hierarchies are just completely different, and in many ways orthogonal to the moral frameworks that were applied, in the Middle Ages, or in the early Renaissance. I guess there is a difference here in the sense that at least we are still running on the same fundamental hardware or something very similar. Maybe that ensures a minimum level of alignment, but does this analogy break apart in some way?
I think that's a pretty good intuition pump. Like there are some ways that the analogy breaks. Like for example, well, the analogy doesn't break so much as like I would like, say put a little bit less weight on it for these reasons. Like one is, in child rearing, you have some influence over children, but you don't get to like, do a full training process where you give them gradients for every like single time step of action that they ever do. So you might hope that like, within given that you can have way, way, way more selection pressure on AI systems, you would be able to avoid this problem. But yes, I think that is, the same fundamental dynamic that I'm pointing at. You get to do you have some amount of influence over, these agents, but, those agents then like encounter new situations and they do something in those situations, and you didn't think about those situations ahead of time and you didn't train them to do the right thing.
Then I definitely buy the idea here that this AI risk, this is really significant risk, and the stakes are very high. When it comes to the solutions or the strategies that you think are most promising, you yourself are specialized, obviously, in one category. Everybody has to be in one subspace within the alignment problem domain. What is the area that you've decided to focus on, and why do you think that sort of is most deserving of attention at this point?
The story that I've told you so far is one of generalization. Like the main issue is, we don't know how to generalize, and, plausibly you could get AI systems that are like single-mindedly pursuing power, and that's sort of similar to the superintelligence story, and those could cause human extinction. But like the sort of fundamental mechanism is like bad generalization, or generalization that's like your capabilities generalize, you do something coherent and high impact, but the objective or the thing you're trying to do doesn't generalize relative to like what humans wanted. And so like a lot of the things I'm most excited about are somehow generalization related. So like one thing that I'm interested in is like, can we like get a better understanding of empirically how do neural nets tend to generalize? Can we say anything about this? There's a lot of theory that tries to explain why neural nets have like as good generalization power as they do. It can't be explained by statistical learning theory because neural nets can memorize random noise, but nonetheless seem to generalize reasonably well on, when the labels are not random noise.
And sorry, do you mind explaining statistical learning theory as a reference? I'm actually not so sure that I ken to the connection.
So statistical learning theory is like a branch of machine learning theory that, tries to do several things, but among other things, try to prove that if we train a machine learning model on, such and such training data with such and such properties, then we know that it will generalize in such and such way. And it like proves theorems about this. And sort of importantly, most approaches right now focus on making assumptions about your model, your hypothesis class. These assumptions usually like preclude the ability to overfit to an arbitrary size data set. Because if you could, then you like can't really say anything about generalization. But the fact of the matter is neural nets really can just actually overfit to any data set. They can memorize labels that are literal random noise. And so these assumptions just don't apply to neural nets. So the thing I'm excited about is like, can we talk about like assumptions on the data set rather than just the model? And using, if we think about assumptions on the data set and assumptions on the model, can we then say something about how neural nets tend to generalize? This is like a super vague, not fleshed out hope that I have not really started working on, nor to my knowledge has anyone else. There's just so many empirical things about neural nets that are so deeply confusing to me, like deep double descent. I don't get it. It's an empirical phenomenon. If you don't know it, you can look it up. It's probably not that worth me going into. Just so confusing. I don't know why it happens. It makes no sense to me. And I will like want to know why. And like, I think that if we like understood things like this, we could start, we might be able to start making statements about how neural nets tend to generalize, and like maybe that translates into things we can say about safety.
That's interesting, because the generalization story seems to be like one ingredient of the problem, of course, and then the other ingredient, which, I mean, there's some overlap, but it does seem like they have distinct components, is this challenge of like telling machines what human preferences even are. Like, our ability to tell each other what we want out of life is already so limited. And it's something that, I mean, at least I personally find somewhat jarring as a prospect, of having to actually not only express our preference, but quantify them and etch them into some kind of loss function that we then feed to a model. You've done a lot of interesting work on this. And actually, there's one of your papers I wanted to talk about. We discussed this before we started recording, and I was so glad to hear that it was also the one that you thought was the most interesting. So we have compatible views, at least on that. But it was this idea of, the paper's title is Preferences Implicit in the State of the World. And I guess first I wanted to ask a question to set the scene a little bit. So what is preference learning? What is that concept?
Yeah. So this was actually the next thing I was going to say I was excited by.
Oh, great.
Which is, I've talked about generalization, but like before you get to generalization, you want to train on the right thing in the first place. That seems like a good, starting point for your AI system. If you don't have that, you're probably hosed. And so, lots of ink has been spilled on like how it's actually very difficult to specify what you want, by writing a program or an equation that just captures it in a number, which is, how deep reinforcement learning or any deep learning system works. But it's, most commonly associated with deep reinforcement learning. And so the idea of preference learning is, rather than having to specify what you want via writing down an equation, you specify it by some easier method. Like, for example, you could look at two trajectories in a reinforcement learning setting. You can look at two behaviors that the agent took, and you can say, yes, the left one, that one was better. And that's, giving the agent some feedback about what it should be doing. It's not, trying to write down an equation that captures the ideal behavior in every possible scenario. Mm-hmm. It's just saying, out of these two, which one is better? And so you would imagine that that's, easier for humans to do and more likely to be correct. And so this preference learning field, I sort of think of it as like the field of how do we design mechanisms for humans to give feedback to an AI system such that, such that we can actually give feedback that incentivizes the behaviors we actually want. And, we don't make as many mistakes in specification as we do with reward functions.
So what I find really exciting about that aspect of it too is there's this well-known difference in humans between expressed desires and revealed desires, or expressed intent and revealed intent. I'll say I want to work out for 3 hours today. I want to do a bunch of coding, and I want to just have a bunch of vegan meals for the next month. And then if you check in on me next month, I will not have done all of those things. I won't have done nearly all those things. And the question is which me is me? I mean, am I the aspirational self that said, hey, I would love to be that person? Or am I the jackass who actually sat on his couch and watched Netflix the entire time? This seems to really scratch that itch in the sense that it probes our revealed preferences, for better or for worse. I guess that could also be a failure mode. Is that something that you see as valuable in this approach?
Yeah, I think you want to use both sources of information and not do either one. So actually, let me take a step back and distinguish between two different things you could be trying to do. So there's one thing where you're trying to learn what humans value, which is the sort of thing that you're talking about. And there's another framing where you're just I want my AI system to do such and such task, and I want to train it to do that. But I can't write down a reward function for that task. I'm actually more interested in the latter, honestly. But the former is also something I've, spent a lot of time on and I'm excited by. So, right now we're talking about the former.
Can I ask a naive question? I mean, I think I understand what the difference is, but I just want to put it to you to tackle it explicitly. What is the difference between those two things?
Yeah. So one thing is maybe I want my AI system to vacuum my floors. Or something. And the task of vacuuming my floors is not well specified just by that sentence. Anyone who has a Roomba can probably tell you stories of the Roomba being super dumb. And like some of those are just the Roomba not being intelligent enough, but some are also just like the task is not super well specified. Like, you know, should the agent, you know, vacuum underneath a Christmas tree where there's like, you know, a bunch of needles that might ruin their vacuum? Who knows? If there's like some like a random shiny button on the floor, should it be vacuumed up or just left alone? Because like maybe that button's important. What sorts of things, you know, should the cat ever be vacuumed? Like, you know, the cat has a lot of hair that gets everywhere. If you vacuum the cat, that seems like it would make your house cleaner. There's like lots of ambiguity here. I wouldn't really say that these are like human values. Like teaching a Roomba how to vacuum does not seem to be the same thing as like, you know, teaching the Roomba about human values. For one thing, like you just can't really talk that much about revealed preferences here because you know I don't vacuum my house very often. You know, if an AI system were going to vacuum, I might have it vacuum more often. But you know,
would you say this is like it's like a narrow application of human preferences? Like it almost seems like the distinction between, you know, narrow AI and AGI somehow maps onto this.
yeah, and I think I agree with that. And I would say like, you know, but in this sense, like everything is narrow AI. You just like get narrow AI that becomes more and more general. At some point, we decide to stop calling it narrow AI and we start to call it AGI because of how broad it has become. But I like the idea of like, you know, you start with something that, you know, can be applied to systems today and like you just scale it up. It just becomes more and more capable, more and more general, but it's always the same technique. And like, you know, eventually the systems that we create with it, we would label them as AGI or human level intelligent or super intelligent. But like, you know, it's the same technique. It's the same sort of general principle. So that's sort of why I'm more excited by this framing of the problem rather than the human values framing. But you know, as you get to like more general systems, it sort of merges in with the human values. Like, you know, once you get AI systems that are like designing government policies or something, like whatever feedback you're giving them, it better teach them about human values.
Yeah. And hopefully, I guess we start to do that at higher and higher levels of abstraction, as you say, as we sort of climb that ladder. We fill in the convolutional filters in a sense as we go up.
Yes, exactly. You had asked a question about revealed preferences versus spoken preferences or expressed preferences. And I think like, yes, this is an important distinction. I am like, you know, I definitely want any method that we propose to like not be dependent on one or the other, but to instead be like using both. And there will be conflicts. I'm mostly hoping that, you know, we can just sort of like have AI systems that like just set aside the conflicts and do things that are like that are robustly good and like that are robustly good according to either set. Probably, you know, you'll have to have some amount of conflict resolution mechanism, but like, you know, humans already have to do this in some sense. So it's like seems plausible that we could do it. But yeah, I think it is, you know, good. A like very nice aspect of this is that you don't have to commit yourself to like defining the behavior upfront in every possible situation. We just don't know this. Like, our values are not well defined enough, honestly, for that to be right. We like our values are constantly in the process of being updated as we encounter new situations. Like, you know, right now we talk about democracy, one vote per person. You know, if someday in the, you know, transhumanist future, if someday it becomes possible to just like, you know, make copies of people, I think we would pretty quickly no longer want to have one vote per person. Because otherwise you can just, you know, pay to have anyone elected if you are sufficiently rich.
Or I guess even in just in the limit of better information about brain states, we could say, well, you know, sure, this policy makes the majority of people happier, but the people it makes more unhappy, I mean, look at that horrible dopamine cycle. Like those people are really taking a big hit, and you kind of like weight those responses.
Yeah, that is, you could definitely optimize better for social welfare potentially. And maybe then you don't want to just have one vote per person.
Right. Now, I guess this brings us back to preferences implicit in the state of the world. There are things,
Yes.
presumably, about the structure of the world that reveal our, I guess this is revealed preferences mostly, right? What we've actually
Yes.
done.
Yep. This is definitely a revealed preferences method. Um, and I think like an important aspect of this is like, you know, people will, I think like the one of the reasons I'm especially excited about this, which I want to say as a prelude, is that like it's not trying to do the hard things. Like when people think about value learning, they think about, should a self-driving car, like, if it's like has a choice between running into two passengers or like killing the driver, what should it do? And, those are hard ethical questions. I'm like, less interested in them. I want to, start with, can we get an AI system that like reliably, knows that it should not kill humans if
Yeah.
there's, if there's if there are two options where, anyway, like the basic stuff that we all agree on,
Yeah.
or nearly all agree on. And so like this, I think like looking at the state of the world is a good way to like see this. And the basic intuition here is that, we've been acting in the world for so long. We have preferences. We've been like rearranging the world to fit the way that, we want the world to be. And so as a result, you can sort of like invert that process to figure out what things we probably want. And so there's this nice toy example that illustrates this. Like, suppose, there's a room, and in the middle of the room, there's this breakable vase. And vases, once they're broken, they can never be repaired. We assume that the AI knows this. We're going to assume that the AI knows all like empirical facts. It knows how the world works. It knows, what actions the human can take. It knows what actions it itself can take. It knows like what states of the world are possible, but it doesn't know anything about like the reward function, or which is, the equivalent of human values. So it knows empirical facts. It knows that this vase, once broken, cannot be fixed. We're going to leave aside glue and, things like that.
Yeah.
And, it then looks at the fact that, it sees, it like is deployed in this room, and it sees that, its human, who I'll call Alice, is like, is in the room, and the vase is unbroken. And so then now you can like pose hypothetical questions like, all right, well, what would I have expected to see if Alice wanted to break the vase?
Mm-hmm.
Well, I would have seen a broken vase.
Yeah.
What would I have expected to see if Alice didn't care about the vase? Well, probably, at some point, the most efficient way would have been to just walk through the room while knocking over the vase. And so probably in that case, also, I would have seen a broken vase. What would I expect to see if Alice did not want the vase to be, or actively wanted the vase to not be broken? In that case, I, actually see an unbroken vase, probably. And since I actually see an unbroken vase, that tells me that, of those three situations, only the last one seems consistent with my observations. And so probably Alice did not want to break the vase. And so you can infer this fact about that, Alice doesn't want to break the vase just by looking at the state of the world and seeing that the vase is not broken.
It seems like there's a very deep connection here to just like the second law of thermodynamics, and just the universe has like, there's so many more ways to end up in a situation where you have a broken vase. That the mere fact that there isn't a broken vase is a huge piece of information.
Yes.
Like it's the, yeah.
Yeah, exactly. That's exactly right. It is that, yeah.
Like basically
I
to
don't
the
think I have
extent
anything
that,
to add.
well, it just strikes me as like, this is like the physicist instinct in me, but the to the extent that the world looks any different from what we would expect with, pure thermodynamic randomness, the assumption here is those differences come from human preferences, right? I mean, would that be a fair way to characterize the?
Yep, that's right.
And does that imply certain failure modes then? Because I guess we encode information in our environment. I guess this is back to the revealed preferences thing, but like implicitly, I've hard coded my brain state into my apartment, every arrangement of things, any kind of like any misogyny, any racism, any foot fetishes that I might have, like the whole laundry list of weird quirks that may or may not be part of my personality are implicitly encoded in the room.
Yes.
Is this part of the risk of applying a technique like this?
Yeah. So, I mean, in theory, if you supercharge this method, it would,
Right.
yeah, it's just going to get everything that is a revealed preference. And there are, well, I don't know that it gets everything, but like to a first approximation, it gets your real revealed preferences. I'm sure there are some that it does not get. And sometimes you just don't like your revealed preferences and you think they should be different. Like, you have a revealed preference. Many people have a revealed preference to procrastinate that they probably do not, in fact, endorse.
Right.
And they wouldn't want, their AI system giving them more and more addictive material so that they can procrastinate better.
Yeah.
Which, is plausibly something that could happen. I would have to think significantly harder about how exactly concretely that could happen, but I could believe that would be an effect. Similarly, the technique, as I've explained it so far, assumes that there is only one human in the world. And things get a lot more complicated if there are multiple humans, and I have just ignored that case so far.
I mean, it's what you need to get the thing off the ground, right? I mean,
yeah.
And
yeah.
Is there, because like in this context, I guess I imagine at least there's another sort of risk mode, which is, if by pure chance, like let's say in the example with the vase, let's say that the human actually doesn't care about the vase, but just happens in her demonstration to have avoided the vase. Is there the risk that, I guess this is always a risk in machine learning. It sounds like just a case of added distribution sampling, like that.
Yep.
You learn that. Okay.
Yeah, that's right. So so there is, if the vase is kept in an inconspicuous, out of the way location, where it's not actually that likely that Alice would have broken the vase in the course of moving around the room. We actually have this in the paper. We show that in that sort of an environment, you actually don't learn anything significant about the vase. You're just maybe she probably didn't want it broken. You
right.
You infer that she did not, deeply desire for the vase to be broken, but you don't infer anything stronger than that. You're uncertain between whether it's, negative versus whether it's bad to break vases versus just it doesn't really matter.
Interesting.
It's more if there were efficiency gains to be had by breaking the vase,
right.
then you infer, and you observe that actually the vase wasn't broken, then you infer that it's bad to break vases. It's still possible that humans, we're not perfect, optimal people. We might not pick up an efficiency gain.
Yeah.
And so we might go around a vase, even though it would be faster to go to the base, even if we didn't care about the base. And then, this method would make an incorrect inference. In general, in preference learning, there's a big tension between you're assuming that humans do the things that
right.
The things that the humans do reflect what they want, and not always true.
Right. And sometimes just for reasons of pure stupidity as well, I guess.
Yeah.
We may want a thing, just not know how to make it happen.
Yep, exactly. That is a big challenge in preference learning. And people have tried to tackle it, including me actually, but I wouldn't say that and there's been super substantial progress on separating, stupidity from things you actually wanted.
I think we'd end up solving a lot of other problems incidentally if we could do that. Yeah.
Yeah.
Actually, there's one more aspect I wanted to ask you about with respect to the paper. The role of time horizons, or the role that time horizons play in the paper is, I think, just really interesting, because there's certain assumptions that the robot makes or the AI makes about what is the time horizon that the human has in mind for this action that like if those assumptions about that time horizon shift, you start to see different behavior. I just love to hear you expand on that and kind of describe that setting a little bit.
I think the main takeaway from that I think I would have about time horizons is like, if you assume a short time horizon, then, you know, cases where the state hasn't been fully optimized are much more excusable, because, you know, the human just hasn't had enough time to fully optimize the state towards what would be optimal for them.
And
so
sorry,
you can,
maybe I should fill in that gap. I realize it was a little ambiguous, but by time horizon, I guess we're talking here about the amount of time that the human would have to, say, go from one point in the room to a desired endpoint, right? To complete.
Yeah, it's like the amount of time that the robot assumes the human has been acting in the environment before the robot showed up. In the room case, it's like, you know, the robot is deployed and it sees an intact vase, and it's like, ah, yes, the human has been walking around this room for an hour.
Right.
Something
And
like that.
if you've been walking around the room for like a full hour and the vase is still there, you can then assume that the vase is probably pretty important to.
Yeah, something along those lines. Exactly. The like actual setting in the paper is slightly different, but that's the right intuition. And yeah, and so this isn't illustrated best with like the vase example, but like imagine you're trying to build a house of cards. This is another example where like the state of the world is really very informative about your preferences. House of cards are like super, super not entropic.
Yeah.
You can infer a lot.
Yeah. Yeah, the more specific the arrangement, I guess, the more, which is interesting because that's exactly what's, I guess, so challenging about just preserving humanity in general. There's like almost a philosophically conservative streak to this approach, in the sense that we're assuming that, you know, we've gotten to somewhere that's worth preserving because we've encoded so much of ourselves, so much of what's good about us already in the environment. And it almost seems like what I love about this time horizon stuff is the political philosophy behind it. It almost gives you a dial that you can tune from the kind of progressive to the conservative end of the spectrum, just by assuming, right, different time horizons. If you assume that we just got here and it's sort of blank slate, then hey, we can try anything. We're not really certain about what humans want in this environment. But conversely, right? Yeah.
That's true. I'd never actually thought of it that way, but you're right. That is basically what it is. Like, another way of thinking about it is like, you know, I the way I actually like got to this point, to the point of writing this paper, was like asking myself, you know, why is it that we privilege the do nothing action? Like, you know, we'll say that like the safe action is to do nothing. Why? It's just an action. And you know, this is an answer. This is like, we've already optimized the environment. Random actions are probably, you know, so the like current state is like, you know, high on our preference ranking. Random actions take us out of that state into some random other state. So, you know, probably an expectation they go lower in our ranking, whereas the do nothing action preserves it. And so it's good. And, you know, the longer the time horizon, the stronger the stronger you want to like do nothing as a default.
Yeah, I remember reading that in the paper actually as almost a derivation of that intuition, which is just it's so beautiful when you can see it kind of laid out like that.
I know.
It's like a,
so good.
Yeah. I mean, in a way, it makes me think of like, you know, so many arguments among and between people of different political stripes could be so much easier if we applied toy models like this, where you can say, well, hey, you know, there is value to the conservative, there's value to the progressive. You know, we end up in a dystopia either way, and here's the parameter we can tune to see how dystopic things get one way or the other, depending on how much we value things. I love the work, and I thought it was, anyway, just, again, one of these sort of aha moments for anybody who is interested in the intersection between kind of philosophy, moral philosophy, and then an AI. It's just, anyway, just such a cool piece of work.
Yeah, thanks. I like it for basically the same reasons.
Sweet. Well, I'm glad we have compatible aesthetics then. Awesome. Well, I think we're covered a lot of the bases here, but was there anything else you wanted to talk about? I mean, one thing I do want to make sure we get to is a reference to the alignment newsletter that you put out. I think everybody should check that out, especially if you're looking to get into the space. Rohin puts out this amazing newsletter, and you can get it anyway. We'll link to it on the blog post that'll come with the podcast. But do you have any social media links or things like that you want to share?
think the alignment newsletter is like the best way to get, my current thinking on things. If you're new to the space, I probably, recommend other things. So specific writing of mine, I like that I like as more introductory. It's not exactly introductory, but more timeless material. On the alignment forum, there is a sequence of blog posts called the value learning sequence that I wrote. I like that as a good introduction. Also, there's also like there are two other recommended sequences on that forum that I also recommend, that I also think are pretty great. In terms of social media, I have a Twitter. It's Rohin M. Shah, but mostly it just sends out the alignment newsletter links. People can also feel free to email me. My email is on my website. I can't guarantee that I will send you a response because I do actually get a lot of email. But I think I have a fairly high response rate.
Yeah, well, I can vouch for that at my end. Thanks for making the time. Really appreciate it, and I'm really looking forward actually to putting this out. And also, good luck with DeepMind, because you're heading over there in a couple of days, really, right?
Yeah, I'm heading there on Monday. It's 2 more business days.
All right. Yeah. Enjoy the long weekend, such as it is.
Cool. Thanks.
Awesome. Thanks so much, Rohin.